Hi everyone. In this video I'll be going through 11.6 and 11.7. So we're going to finally be using the quadratic formula to solve some of these quadratic equations. All of the quadratic equations you've solved by factoring or the square root property or some other method, all of those can be solved using just this formula here. So what this is saying is if you can rewrite your quadratic equation in this form, then this is exactly how you can solve that quadratic equation. So this A is the same as this A and this A. This B is the same as this B and this B. And that C is the same as that C. So let me show you how this works out in practice. So I do have that this thing is equal to 0. So in other words, I can say, yep, I have this. Now I can go ahead and use this formula. Okay, so I have A, in this case, is always the number attached to the squared term. So A in this case is 2. B is always attached to the x term. So B in this case is 9. And C is always this pure number, just without the variable, so -5. So now I can reference this formula, plug in, and I'll get my solutions that easily. So x would equal, it says -b, so the opposite of 9, in other words. So -9 plus and minus the square root of 9 squared, right? It's b squared, minus 4 times a. A is 2. Times c, which is -5. And then notice that this fraction bar goes all the way underneath. So a fraction bar comes all the way underneath that. And then we have 2 times 2, 2 times a. Okay. So over here, I'll try to type this in so you guys can see this. So first things first, you want to hit the fraction, create a fraction. And now I'm going to type in all this stuff here. So -9 plus the square root of 9 squared minus 4 times 2 times -5 over 2 times 2. So this is one of our solutions, this 1/2. So x equals 1/2 apparently is one of our solutions. What you can now do, because we also need to do the minus case, is you can scroll left a bunch of times till you get over there, change that to subtract. So we also have that -5 works. So maybe I'll check this with -5. So the claim would be that -5, when plugged in, solves this equation here. So I can say, since -5 is appearing in the screen, I can say 2 times answer squared plus 9 times answer minus 5. This should be 0, and it is. I'm assuming that 1/2 also works. Okay, let's try another one. So on part 2, notice the big difference is that we do not have this yet. It is not equal to 0 right out of the gate, right? So we want to adjust that. So I'm just going to pick a side for 0. It does not matter what side I pick for 0. So I'll bring everything to the right. I'll subtract this 2x squared. You could have brought everything to the left. It really does not matter. 0 equals -2x squared plus 6x minus 1. So in this case, now I do have that this thing equals 0. So now I can go ahead and use this formula. It's not until it equals 0 that you have properly defined a, b, and c. So a is always attached to the squared term. So that's negative 2. B is always attached to the linear term, so that'll be 6. And C is this pure number, negative 1. So the formula says x will be opposite of b plus and minus the square root of b squared minus 4ac all over 2a. So that's the formula I'm going to use. So we have x equals opposite of 6, so negative 6, plus and minus the square root of 6 squared minus 4 times negative 2 times negative 1 over 2 times negative 2. So I'll type that in here. So fraction first, negative 6 plus square root of 6 squared minus 4 times negative 2 times negative 1 over 2 times negative 2. So I'm getting this number. And then again, I want to go back and change that addition to subtraction. So I get these two answers. I can check these. So maybe I'll go back and I'll plug it into this one actually, which is an equivalent form of our original problem. But I'll just be able to check to see if this indeed does give a 0. So I can say negative 2 times answer squared plus 6 times answer minus 1. And this should be 0. It is. So I'm assuming both of these work. On to page 110. I'm leaving this one undone. I'll do that and attach the solution, of course, alongside the video. Let's go on to an application problem. I had some scribbles in my notebook from some random event in the past, so don't mind this. I'll do the problem around it. It says a local model rocket club launches a rocket that follows the path given by this equation. H equals negative 16t squared plus 120t plus 2. Here, t is the time in seconds after the launch, and h is the height of the rocket in feet, t seconds after launch. The students in the club want to know when the rocket will hit the ground. When will the rocket hit the ground? And then there's this follow-up question. Do both answers make sense? So here's our equation that models this rocket. So if we want to know when this thing hits the ground, we want to know when h is 0. So I'll say instead of h, I'll plug in a 0, and I'll have negative 16t squared plus 120t plus 2. So I need to solve this equation now. So this is a quadratic in the variable t. So still I can use my quadratic formula. Right, in this case, it's essentially a t squared plus bt plus c equals 0. It's not the variable that matters, right? It's just whatever is written there. That's the variable we're working with. So if that's our equation, then the quadratic formula would be t equals opposite of b plus and minus square root b squared minus 4ac over 2a. So that's what I'll use down here. A is negative 16, B is 120, and C is 2 in this particular case. So I'll have that T equals the opposite of 120, so negative 120, plus and minus the square root of 120 squared minus 4 times A times C over 2 times A. I'll go ahead and type this in. Okay. So fraction negative 120 plus square root 120 squared minus 4 times negative 16 times 2 over 2 times negative 16. So I get this as one of my answers. I'll just round this. So this was t plus. I'll just notate it like this so I know that this is from the plus case. Is about negative 0.0166. All right, so I'm just taking the first 4 decimals of that. Scroll back to the left. Replace this addition with subtraction. So I'm getting this as well. So t minus is about equal to 7.5166. So this would be a number of seconds, by the way, for both of these. The first one, though, this is negative. This is a negative time. So with respect to this follow-up question, do both answers make sense? No. So I'm going to throw out this one because we're not going to talk about negative time. So when will the rocket hit the ground? It'll hit the rocket, or the rocket will hit the ground about 7.5 seconds after launch. All right, moving on. So graphing. Go on to a graphing one. I'm going all the way to page 112. Of course, I'll post solutions to the other ones I skipped. So this says sketch a graph of the following function. Please state all intercepts and label the vertex. So when we have a function in this standard form, like we have here, then the vertex would be at opposite of b over 2a, and then f of opposite of b over 2a. So to find the vertex, that's what we'll do. So I have, in this particular case, I have a is 2, b is negative 12, and c is 5. So the vertex part we'll have opposite of negative 12, in other words, 12 over 2 times 2. And then I'll have f of 12 over 2 times 2. So in other words, 12 over 4 is 3. So I have f of 3 to find, and that'll be the location of the vertex, 3, f of 3. So f of 3, plug 3 into our function, we get 2 times 3 squared minus 12 times 3 plus 5. Looks like, let's see, this is 9 times 2, 18 minus 36 plus 5. Negative 13. So in other words, the vertex would be 3 and negative 13. So it looks like I'll actually have to estimate that, because our graph only goes down to negative 10 about. So 3 and negative 13 I'll just place right about here. That's not a great 3. I'll place 3, negative 13 right about here, actually. In what direction does this one open? Because A is positive, this thing opens up. So I know this is our vertex and everything's opening that way. So I'll write this vertex down here, 3, negative 13. We also wanted the intercepts, right? So for x-intercepts, you let f of x, which equals y, equals 0. So I'll have 0 equals 2x squared minus 12x plus 5. So one way to solve that is with the quadratic formula that we've just recently learned. So I have a as 2, b is negative 12, and c is 5. So the solutions for our intercepts would be opposite of negative 12. So 12 plus and minus the square root of negative 12 squared minus 4 times 2 times 5 all over 2 times 2. So I'll type this in. Fraction first. 12 plus square root negative 12 squared minus 4 times 2 times 5 over 2 times 2. So I get this strange number. So x plus, I'll just say it in exact form as 6 plus root 26 over 2. If I go back and make this minus, I'll get the other intercept. So 6 minus root 26 over 2. So I need to plot these. 6 minus is about 0.45. I'll just make a note here of that. The plus case, let me make a note of what that decimal was about. Forgot to do that. S to D, this is about equal to 5.55, I'll say. All right, so I'll go ahead and plot those. Right, our intercepts live on this axis here. And I'm just going to use these numbers in red to approximate them. So 0.45, right about here. Right, a little bit less than half of 1. 5.55, right about here. A little bit more than 5.5. So to fully write the intercepts, so my x-intercepts would be 6 plus root 26 over 2, 0, and 6 minus root 26 over 2, comma 0. These 2 points are the exact x-intercepts. I'm just plotting them with these numbers in red so I can actually find them, because this is kind of, it's hard to tell where these are. All intercepts, so we still need the y-intercept. So the y-intercept, maybe I'll do that up here. So for the y-intercept, we let x equal 0. So f of 0, in other words, would be 2 times 0 squared minus 12 times 0 plus 5. In other words, 5. So that vertical intercept would be 0, 5. So 0, 5. That point, by the way, by symmetry, this is 3 to the left. We're up at 5. So if I'm 3 to the right over here at 6, I should be up at 5 also. So I can use that information. And I'll go ahead and draw a parabola. Okay. All right, I'm skipping all the way to page 114. This will be the last one I do in the video. So it says the net sales for Home Depot can be modeled by this function, where N of T represents the net sales in millions of dollars for Home Depot T years since 1990. It says using this model, estimate the annual net sales for Home Depot in 1995. Okay. So for part 1, 1995 is 5 years since 1990. So I'd have t equals 5. So in other words, n of 5 would need to be found. So 376.5 times 5 squared plus 548.1 times 5 plus 2,318.4. So I'll type this in here. So 376.5 times 5 squared plus 548.1 times 5 plus 2318.4. So I'll write it this way, 14,471.4 . And since N is the net sales in millions of dollars, this would be $14,000.4 million. For part 1. Okay, part 2, it says, when were Home Depot's net sales $30,000 million exactly? So now instead of plugging in for for T, this is now N. This is a number of sales. So I'm going to plug 30,000 in over here. Since it's 30,000 million, it's already in the right units because N counts the number of millions. So 30,000 million means I'm just going to plug in 30,000. So 30,000 would equal 376.5 times t squared plus 548.1 times t plus 2,318.4. So I want to solve this for t, right? When were Home Depot's net sales? So I'm looking for t here. So if I want to use the quadratic formula, I need to get a 0 on one side. So I'll subtract 30,000. Right, I need that 0 to be able to use the quadratic formula. So 0 would equal 376.5 times t squared plus 548.1 times t. And then let's figure out this difference. Minus 30,000. So this is negative 27,681. 0.6. Okay, so to solve this, I'm using the quadratic formula, and I have A is 376.5, I have B is 548.1, and C is this negative 27,681.6. So keep in mind our formula was T equals opposite of B plus and minus the square root of B squared minus 4 times A times C all over 2 times A. So T would equal opposite of B, so opposite of 548.1 plus and minus the square root of 548.1 squared minus 4 times 376.5 times negative 27,681.6 all over 2 times 376.5. So more complicated numbers this time, but same principle. Okay. Fraction negative 548.1 plus the square root 548.1 squared minus 4 times 376.5 times negative 27 681.6 over 2 times 376.5. So t plus is about equal to, maybe I'll just round it to 2 decimal places, 7.88 years. Scroll back, change plus to a minus. This is negative, so t minus is about negative 0.933 or 9.33, and this would be a number of years. However, the negative time, although it's mathematically true, it doesn't fit within the context. So for part 2, it says when were Home Depot's net sales? So I would say this number of years, but after 1990, since T is a number of years since 1990. So I would say they hit, so here's my statement, they hit 30,000 million about 7.88 years after 1990. Part 3 says find the vertex for this model and explain its meaning. Okay. So we had that vertex thing was opposite of B over 2A. So what we need to do is find opposite of B over 2A. So opposite of 548.1, right? I'm looking at B. Opposite of B. So opposite of 548.1 over 2 times A, which is 376.5. And then I need to find N, since the name of the function is N. I need to find N of this. And then I'll have to explain its meaning in a second. Okay, so I'll first start with this one, and then I'll plug that value into N. So I'm going to first type in this thing right here. So negative 548.1 over 2 times 376.5. So this number, unfortunately, but I'll talk about that in a second. So this number, and then since I can save that number, I'm now going to plug that number into here to see what actual value is achieved. So now plugging this in, 376.5 times answer squared, plus 548.1 times answer, plus 2318.4. Okay, so if we think about this, this thing is a parabola. It opens up because of this positive A value. So the vertex that we just found is actually a minimum number of sales, right? Since N represents the number of sales in millions, what we just found, this was the minimum number of sales reached. So it was this amount of time. So I'll say, so the meaning, the lowest net sales was about $2,118.9 million. $1 million, sorry if that was going off the page. which occurred this amount of time before 1990. So I'm going to type in that again just so I can see what number that is. So negative 548.1 over 2 times 376.5. So that was about 3/4 of a year before 1990, which occurred, so I'll say in 1989. Okay, talk to you guys next time.